scores of the students of the two teachers. We're using alpha equals 0.10. And this question will come up on the AP test, which is why I keep asking it to you. It's already obvious that they're different, so why do we do this? Right. Are they close enough that we can assume that, well, they're about the same, or are they far enough away from each other that we can conclusively say, look at this degree of confidence, we can say that these must be different, like these classes are different from each other. So it has to be far enough away. But remember that if we had the whole class here, if it wasn't just a sample, like if I had all of this teacher's students and all of this teacher's students, then there'd be no reason to do this test. Because we're just making a guess about the population based on this sample. So it's not like these are all the kids that they teach. Okay, all right. We're assuming that the population variances are not equal. So, draw a quick bell curve. I mean, that's a pretty good bell curve, guys. Wow, I mean, not as good as Justin's. Justin, you want to bring yours over here? We can show Nathan.
That's pretty good. Looks like Megamind,
Okay.
but
This is,
yep.
this looks like Megamind.
Yeah.
Like his forehead?
Yeah.
All right. So this is a, let's see, H sub O, H sub A. Teacher 1 and teacher 2, mu sub 1. It says, can you conclude that there's a difference? So what does that mean? Right, and which one's the claim? Right, so the claim is that they're different from each other, which means not equal to. This is going to be a two-tailed test. And it says alpha equals 0.1. Okay. Now, you need to know that the degree of freedom, if the variances are not equal, if you look back at that first page, where was my first page? So if you look back at that first page, if it's pooled, the degree of freedom is adding them together and minusing 2. But if the variances are not equal, it's whatever one's smaller. Do you guys remember how the degree of freedom used to be your sample size minus 1? And it's still your sample size minus 1, it's just whichever one's smaller. So now go to A18. So which one's smaller, 8 or 18? 8, and then we're going to minus 1, so now our degree of freedom is 7. And it's a two-tail, 10% in two tails, which I got 1.895. You guys get the same thing? George, are you with us?
Not really.
1.415.
No, because it is two tails for 0.1.
Oh, right.
So are you on A18? The T
Yeah.
table? And are you at 7 on the left?
Yes.
Okay, so you go to 7 on the left, and then you go under the two-tail part. And then do you see how it says 10% under two tails? If you go down there, you get 1.895.
Okay, yeah.
Okay, so that's positive 1.895 over here and negative 1.895 over here. Okay, now we've got to figure out the score to compare it to. So that would be x bar 1 minus x bar 2, which is 473 minus 459. And on the bottom is the square root of the sample standard deviation squared divided by n sub 1 plus the other one squared divided by n sub 2. Go ahead and put that in your calculator. making the headlines out of a hunch. Going for lunch. All right, I got .92. You guys get .92? All right, so that falls right about here, which means, what? Which means that I'm going to accept the null and reject the claim. So I accept the null and reject the claim that the classrooms are different. Guts and glory, I'm the king of New York.
My handwriting is so bad that when I do this, they're like, I can't even read this guy's sentence.
Well, it's only 5 questions, so maybe take your time writing. I mean, think about it this way. If I said, I will give you $3,000 and make you take a class less in college if you can write clearly for 5 sentences.
I don't know.
Like,
Some of us would really struggle to do that.
I mean, write clearly enough for someone else to read it. I think you could do that.
Judgy.
There is no person grading a math test who's gonna be like, look, I can read it, but I don't like how he wrote it, so no. They're going to be able to read it or not be able to read it. They're not gonna be like, ugh, I wish it was in cursive and I wish it was perfect, and it's not, so F. You know, like,
What if they can't read it? Like, what happens?
if they can't read it, then yeah, they're gonna mark it wrong. But I can read your handwriting, even when you're not trying to be nice. So try to be decent and you'll be fine. Yeah, you will try. It's very different. This isn't like me being like, hey, I hope you pass my test. This is like, hey, would you like to get 4 college credits and $3,000 in your bank account? This is a pretty high, like, I don't have to be like, boy, I hope you try hard. Like, I do hope you try hard, but I hope you try hard for you, not for me. You're gonna be like, oh man, I really wish I would have, I was gonna fail it, but then Miss Nussbaum told me she wanted me to pass it, so I guess I will. Like, you're gonna do it on your own. Okay, so on this one, a manufacturer claims that the mean operating cost per miles of its sedans is less than that of its leading competitor. So this is the manufacturer, the manufact. I had enough room for that. Manufact, and this is the what should we write? Competit. Don't like that. Competish. There we go.
Competitish.
Competitish. Sure.
All right.
So, Nathan's like, what are we doing right now? Just get on with it. So the manufacturer, the average is 52 cents per mile. And the competitor is 55 cents per mile. Gasp. And the standard deviation of the manufacturer is 5 cents a mile. And the standard deviation of the competitor is 7 cents a mile. And they sampled 30 cars for the manufacturer and 32